One and welcome. In this lecture, we'll look at a dataset consisting of spam and ham message, and we'll try to build a model and predict whether a message is ham or spam. For that, here is the location of the dataset. It's in UCI's database. So if you go to that URL, you can click on the data folder here and then download this SMS spam collection zip folder and then unzip it where your homebook directory is located. Okay, this is what the SMS spam collection looks like. It consists of ham and spam messages. Or you can use this SMS data.tsv file that I have provided. Okay, let's start uploading the dataset by using both of these options. Okay, and you can use whichever you prefer. So if you have downloaded the folder and then unzip it where your homebook is located, it will have this name, SMS spam collection, upper S and upper C. We can use pandas read CSV method. Let's do that. So if you haven't imported pandas, import pandas. So pd.read CSV, and then we'll pass the name SMS spam collection. Make sure to pass the same name. Whichever is uppercase has to be uppercase, otherwise you'll get an error. And then for separator, we will use tab, and let's pass the names attribute and then pass the following names: label and message, label and message. And let's save this in a variable called SMS messages. Okay, now if we call the head method on our SMS message object, we see that we have two columns, label and message. So the label is whether it's a ham or a spam. Ham basically means not spam. And then we have the actual message. Okay, this is one of the methods. And if you want to use this SMS data.tsv file, for that we'll be using the read table method. So we have our SMS underscore data.tsv file. So if you want to use this option, we'll be using the read table method. So panda dot read table, and then pass your tsv file SMS underscore data dot tsv. Then for header, we'll set it to be none, and then for names we'll pass label and message as we did before. For names, let's pass label and then message, and let's save this in a variable called SMS messages. Okay, run it, and let's check our SMS message by calling the head method. That head. Okay, we have the same result. We have two columns, label and message, whether the label is ham or spam, and the actual message. So feel free to use any of the above two methods. Okay, now let's analyze our SMS message dataset. Let's call the describe method. So if we call this is SMS underscore message. Let's run it again. So if we call the describe method, we have a count of 5,572. We have two unique ones, two unique labels, which are spam and ham, and the top one is ham. We have frequency. Okay, so SMS message, if you call the tail method, you'll see the last 5 rows, right? 5,571. indexing starts with 0. So that's the number of rows that we have. Now let's call the shape method to see the shape of our data set. So SMS message.shape, you'll see that it's 5572 by 2, so number of rows, and 2 is the number of columns. And you can call the value counts method on your labels to see how many of the messages are spam and how many of them are labeled ham. Let's do that. So we have SMS message that label, will index the label column and then call the value counts method on it, and we'll see that we have 4,825 of them are ham messages, whereas 747 of those are spam messages. So our goal is to distinguish whether a message is a spam or a ham, right? But our algorithms won't know spam or ham. So for that, we need to convert these labels into a numerical format, which is 0 and 1, right? Let's do that. Let's add another column, and then we label the spams as, for instance, maybe 0 and the other one as 1. So let's add a new column. We have our SMS message dataset, and then name of our new column, let's call it label underscore number. Then we'll say SMS message will index our label column, and then we can simply call the map method and then pass a dictionary to map our ham to a 0 and our spam to a 1, or vice versa. So for ham, we'll map it to 0, and for spam, we'll map it to 1. Okay. Now let's see if it has worked. So we'll call the dataset dot head. Okay, you see now ham is 0 and spam is 1. Now this is much easier to work with since it's in numerical format. The next thing we'll do is identify our training and then testing datasets, right? What we'll do is we'll train on messages and try to predict whether that message is a spam or ham. Okay, so let's define two variables, and we'll store all of our messages in the variable x, and this label numbers will be saved in a variable y to represent target. Okay, so we have our SMS underscore message, and then we'll index the message column, and our target will be whether it's a spam or a ham. So SMS message dot label underscore number will index the label number columns. Okay, now let's print the shape of our x and y objects. So the shape of x is 5572, and if we also print the shape of the y variable, it will be the same, 5572. So here we see that the shape of our x is one-dimensional, and that's important to remember because when we use the count vectorizer only accepts one-dimensional objects. Okay, and the purpose of the purpose of count vectorizer is to transform this one-dimensional object into a two-dimensional object. Okay? So it's important to pass our count vectorizer a one-dimensional object. Next, let's split our X and Y datasets into training and testing datasets. For that, let's import the train test split method from scikit-learn. So from sklearn.crossValidation, we'll import the method. From sklearn.crossValidation, import train test split. And we'll use this train test split to divide or split our X and Y datasets into training and then testing sets. And we'll store them in 4 separate variables: xtrain, xtest, ytrain and ytest, ytrain and ytest. Again, you can use any variables that you want, it doesn't matter. But you have to be consistent throughout your model. So we'll call our train test split method and then pass our X and Y datasets. And for random state, I'll just pass 13. So if you want to get the same exact result as me, you need to pass a random set of 13. And let's also pass the test size attribute and set it to 0.3. So we'll use 70% of our dataset for training and 30% of the dataset for testing. Okay. Now let's print the shape of our xtrain, xtest, ytrain and ytest. So print xtrain, xtrain.shape, xtest.shape, run it. Okay, so xtrain we have 3900 and for xtest we have 1672. So our training dataset is 70% of the entire dataset, and our testing dataset is 30% of 5572. Similarly, if we print the shape of ytrain and ytest, ytrain.shape and ytest.shape, you'll see the same number, 3900 and 1672, 7030. The next thing we'll do is instantiate the count vectorizer object and then convert our training dataset into document term metrics. So one question you might ask is that why did we split our dataset into training and testing datasets before we instantiate our count vectorizer? The reason is because when you analyze your testing datasets, there will be certain words that your model won't recognize, right? So we want to be able to drop those features as we have seen in the previous lectures. So that's why we are splitting our dataset before we call the count vectorizer object, as some of your training data will not distinguish or know certain words in your testing dataset. And we want to be able to drop those words that our model doesn't know.